Done. All right. So I'll be sharing my screen with you. Okay. Can you see the slide I'm sharing? If you can see the slide I'm sharing, you can type, I can see it. Okay, okay. All right, all right. Yeah. So this is what we'll be looking at briefly in the next couple of minutes before we'll call it a day. I'm Nathaniel Damilarujo, so I'll be handling the acid, basis, salts, and buffer aspects. But for the sake of this class, we'll only be looking at acids and bases. We will not consider the pH, salts, and buffer solution. So we'll just look at acids in our environment, bases in our environment. We'll look at the properties of acid and bases and how we can define an acid and how we can define a base according to established authorities like Arrhenius definition, Bracellaro definition, and the Lewis concept of acids and bases. So note this, before this class ends, you should be able to define what an acid is. You should be able to define what a base is and also list at least two properties of an acid and two properties of a base. All right, so the learning outcomes are you should be able to identify some acids and some bases in your environment and be able to differentiate, okay, this one is an acid, or maybe this one is a base. You should be able to differentiate the two. And all right, yes. So acids are just all around us. We live with them. They live with us. And even if I ask you to type in the comment section some acids that you know in your environment, I want to believe that you'll be able to put something there. So type in the comment section some acids that may be present, maybe at home or maybe around you. Can you type some examples there in the comment section, in the chat section? Let's see. So I know that you are familiar with the concept of acids. Okay. Yes, carboxyl, citric acid. I can see some of you are giving very good examples. Vinegar, okay, acetic acid. Yes, I can see. Olasokomi, okay. God gift. You say you cannot hear me. You can check whether your audio is enabled properly. Okay, carboxyls. I can see some of the examples you are giving, and they are very correct examples. So these are examples of acids that are with us. They live with us, we live with them. They are just all around us. But just like electricity, if you have a live wire, you'll be looking at it, this live wire, is it a friend to me or is it an enemy to me? Is it a friend? Is it a foe? Is it helping me? When you put your TV on, when you are charging your phone, or maybe you put on your freezer and then you're enjoying it, you see the electricity as a friend. But if by mistake someone touches live wire, that's dangerous. So acids, are they a danger or are they a darling? Are they friends to us or are they foes to us? So that is what we look at. So just like some of the examples you have typed there, we have acids around us and some of them are very beneficial to us. Like aspirin, some of the medicine that you take when you are not feeling fine and doctors recommend them. Some of them contain acid. Some unripe fruits are rich in acids. Sour milk also contains acid. Also in our stomach, we have the stomach acid, that is dilute hydrochloric acid. And that aids digestion in our stomach. And sometimes when it rains and you take a litmus paper to test the pH or to test whether that rainwater is acidic or alkaline, you may be able to observe that the litmus paper can change, the color can change, which means that the rainwater you have just collected may not be neutral. It may either be acidic if what you have collected is an acid rain, but it may also have another pH entirely, depending on where you are. So we have some common examples of acids. You know, some of you take all these carbonated drinks. Maybe you haven't taken it this week, or maybe today or yesterday. The carbonated drink you have taken contains compressed gas, that's CO2. And in solution, it exists like carbonic acid, H2CO3. That is an acid. The electrolyte in the car battery is also an acid. That is H2SO4. That is dilute tetroxysulfate 6 acid. That's an acid. And that same acid can be used to make some synthetic fibers, some dyes, some paints, and so many other things that industries use the acid to do. Nitric acid, which is HNO3, that's triazonitrate 5 acid, is another acid that is used to make fertilizers. So all these inorganic, these synthetic fertilizers. Then HCl is present in our stomach. I've already said that, and it helps some enzymes in our stomach to work properly. Those who are in the biological sciences will be able to expatiate further on that. Then acetic acid, some people use it in the kitchen in form of vinegar, and there are some things they use it to do, especially in cooking. Those who are into catering services, they are familiar with that. The citric acid in fruits, salicylic acid, salicylic acid, even the malic acid that is present in apple. All right, at this point, I will need to give you a very short assignment so you can write it somewhere. So now look at this malic acid that I've typed here. I will try and type something else to see. Okay, so now we have malic acid and we have malic acid. Are they the same thing? Malic acid and malic acid, are they the same thing? Is there a difference between them? Are they just essentially the same? So you find out about this and see, and maybe give me a feedback. I will still put the question in the forum on elements so that you can answer that. Are they the same thing? Malic acid. We also have malonic acid. Are they the same thing? Just Google it or browse it or get information from the textbook and see whether the structure, the formula, the uses, maybe the source, maybe all those things are the same or maybe they are not the same. Okay. All right, let's move on. So you can have some of these fizzy drinks, some of these carbonated drinks. They are rich in acid. The car battery, you can see the picture there. That's car battery. We have the electrolyte there is an acid. And then when you see rusting materials around you, maybe some metals that have undergone rusting, those metals are undergoing rusting due to the environment, and acids facilitate the rate of rusting. When you come back, maybe when you are on ground physically, someone will be taking you chemical kinetics. The person will introduce you to the rate of reactions, how reaction can become fast or how it can slow down the rate of a reaction. So another lecturer will expose you to that. Now that we know about the acids around us, how about the bases around us? So sometimes when you are feeling some upset in your stomach, maybe the acid content in your stomach has increased, but you don't know what was happening there, and you complain to a pharmacist or maybe to a doctor, then they recommend some antacids for you. Those antacids are essentially bases. There may be some other things in them, but they're essentially bases, and they have the ability to neutralize or suppress or try to reduce the concentration or the potency of the acid in your stomach. And that is why maybe if you have taken them later on, you may feel better. Then you feel like, okay, what the doctor has recommended is working for you. So some of them are bases. An example of that is the milk of magnesia. So this milk of magnesia is essentially a base. And some people take it so that they can feel better, especially when recommended. So don't take something that is not recommended. And some of you who have been involved in washing, whether with the bar soap or detergent and all that, when you touch soap that is already in water, you see that it is slippery. When you touch it, you feel like your hand, it has this characteristic soapy feeling or soapy texture. So that is as a result of the presence of bases in them. So bases can have its own characteristic texture. So let's look at properties of acids and bases. From secondary school, you've already been told that acids have sour taste. An acid has a sour taste. Possibly somebody tasted something that is sour, maybe sour milk, and then they tested it and they know that it contains an acid. And that's why they said acid has sour taste. This doesn't mean that when you see an acid in the lab, you should put your tongue there. Whatever you see in the lab, just take them as if they are dangerous. Just treat them as if you don't want to go near them because you don't know whether they are dangerous or not. In fact, even if it looks like water, you don't touch it. You don't allow it to touch your skin. Don't allow it to touch your friend, let alone touching your enemy. So do away with anything you see in the lab and abide by all the instructions the technologists or lecturers will be giving you. So if they don't ask you to touch it, don't touch it. And don't taste anything in the lab. Don't put your nose inside anything in the lab except you are told to do that. But even if you are told to do that, you don't put your nose inside anything. There's a standard way of doing that. You'll be told later. The concentrated acids, they're corrosive, very dangerous. They can burn skin. They can burn materials. They can burn organic materials. As if you have put fire there. They will burn it. The thing will, it will be as if it will just get destroyed. And that is the potency of concentrated acids. So you don't allow it to touch you. Don't allow it to touch your skin or to touch anyone or anything around you. And also, we know that acids, when you put a blue litmus paper inside it, then the litmus paper can turn red. You're familiar with that from secondary school. The pH of an acid is between 0 and 6 and all that, typically less than 7. And acids are soluble in water. Then they are good conductors of electricity, especially when they are arenous acids. And we have the chemical properties also. They can liberate gas, hydrogen gas, especially when they react with active metals like sodium, like potassium, and all that. They can liberate hydrogen gas. And an acid can be neutralized by a base. When an acid reacts with an alkali, it can form salt and water. We call that neutralization reaction. You are familiar with that from secondary school days. So before we move on, I told you from the beginning that you should be able to mention 2 properties of an acid. So now type in the comment section 2 properties of an acid. I will make the screen blank now so that you should be able to type. So type under the chat section 2 properties from what I've said so far. Is it sour? Is it this? Is it that? Type 2 properties there in the chat section. All right. I can see some of your responses. It has sour taste. The pH is less than 7. Okay, it's corrosive. That's very good. I know you are very brilliant. You are following. Yes, very brilliant. Yes, I can see. It undergoes neutralization reaction. All right. Some of you type so fast. Okay. Yeah, you're doing very well. Very well. All right. Very good. Yes, it can burn the skin. It's corrosive. Okay, that's Oluwasegun Tayo. That's very correct also. That's very correct. Then someone typed, aqueous acida, electric conductor. Which language is that? Is it English language? Well, maybe someone will help us to translate it to the English you are familiar with. All right. So I can see that you are all following what we're trying to do. Okay, so far, is there any question? Can we just take maybe 1 or 2 questions before we move on? Okay, so if you have a question, you can raise your hand. Let me see whether I can see any hand raised. Let's see. I can't see any. Okay, Ari Bike Victor. Is it Harry Bike or Harry Bike? Well, I don't know how to pronounce the name, but you can omit yourself
Okay, so sir, you said arenous acid are soluble in water.
Okay, so what's
Yes,
your
sir.
question there? Hello?
What are arenous acids?
All right, we'll get there. We are just taking it step by step. It's part of the objective of this session. So we'll get to the definition of what an arenous acid is, what an arenous base is. Okay, Arabic. So you can mute yourself back. Okay, HU, HU wisdom, HU wisdom. Are you there, HU wisdom? Okay. HU wisdom, are you there? Okay. Well, I think it's not available right now. All right, let's go to Akin. Akin, who is this now? Is he Akin Lon? Okay. Well,
It's Akilonu, sir.
okay, okay.
Akilonu.
All right.
Yes, sir.
Good morning.
My question is not actually about the class, but we learned that some people are in the waiting room, so maybe you could allow them join so they can participate in the class, sir.
Okay, the class is already full. It can take a maximum of 300. So
We are actually.
even I'm trying to admit all of them right now and see how many of them will still be able to join us. So I've tried to admit them. So let's see. It seems some of them are actually coming in right now. All right. Yeah, thank you, Faith. Okay. Idayat, Ajoke.
Good morning, sir.
Yeah, good morning, Idayat.
Sir, I want to ask a question concerning where you said acids do conduct electricity. So my
Okay.
question is, does HNO3 does it also conduct electricity?
HNO3.
Yes.
Okay, nitric acid.
Yes, sir.
Yes, it can if you take some portion of it, you dissolve it in water. You know, you add acid to water, you don't add water to
Yes,
acid. So if you take little
exactly.
portion, maybe some volume of that HNO3 and you dissolve it in water, then it should be able to conduct electricity. But be very careful, electricity is dangerous. So we don't
Yes, sir.
play with it. Okay. It can conduct.
Thank
All
you,
right.
sir. Oh, yeah.
Yeah, you can. Okay, you can mute yourself now. All right. Okay, let's move on. I can see so many hands up, but we may not be able to accommodate all the questions right now. But we'll create a forum in which you'll be able to put all your questions, all your comments, your observations, you'll be able to put them. I can see so many hands up. Well, no problem, but let's just move on. Someone has already asked the question about the Arrhenius definition of an acid. We'll soon get there. So let's look at the properties of a base. We said it has bitter taste, slippery to touch, concentrated bases, just like that of acid. They are also very corrosive. And unlike an acid that turns blue litmus paper red, a base can turn moist red litmus paper blue. That is, if you have a blue litmus paper and you put it in an acid and it has turned to red, you can take that litmus paper and put it back on the base. It should be able to turn to blue. That's what a base can do. And some bases are also good conductors of electricity, but their home pH is above 7. It's 7 point something on 8 or 9, down to 14. And bases that are soluble in water, we call them alkali. And they also have their own chemical properties. Transition reaction is an example of that. And alkalis can also liberate ammonia gas, especially when they react with ammonium salt. An example is what we have here, where we have calcium hydroxide reacting with ammonium tetrasulfate 6. Well, you eat it a little bit And then we have ammonia gas liberated. Water and CaSO4 also formed. Okay, an alkali can also precipitate in insoluble metal hydroxide. For example, if you have sodium hydroxide, it can react with copper-2 tetrasulfate 6, and that will form an insoluble salt, which is CuOH2. Then we have a soluble salt, which is sodium salt, Na2SO4. Then apart from all this, there is a property, there's one property that is not general to all bases, and that is the reaction with metal. A strong alkali like sodium hydroxide can actually liberate hydrogen gas when it reacts with this aluminum. But that is not a general reaction. That's just a very special reaction between aluminum and strong alkali like sodium hydroxide. So that forms sodium aluminate and hydrogen gas liberated. So in the next section, we'll be looking at the definition of acid. Some of you have asked, so how do we define an acid according to Arrhenius, Bronsted-Lowry, and all that? What is the definition? So what is an acid? What is an acid? According to Arrhenius, an acid is a substance that produces hydrogen ions or hydronium ions when you dissolve them in water. That is the definition, possibly the early definitions you were exposed to, maybe in secondary school, maybe in GS class or in your SS class, that an acid releases hydrogen ions or hydronium ions when you dissolve them in water. That is Arrhenius' theory of an acid. And based on that, we can classify acids into non-oxygen acids and oxygen acids. Monoprotic acid, diprotic, triprotic, depending on the number of replaceable hydrogen ions we have in the acid. Then we can also divide them into strong acid, weak acid. Okay. The ones we call non-oxygen acids, those ones do not have oxygen atom in them. An example is hydrochloric acid. Hydrochloric acid is HCl. There is no oxygen atom in HCl. Then we have hydroiodic acid, and we also have cyanic acid. These ones are also acids, but they don't have oxygen in them. Unlike H2SO4, H2SO4, H2SO3, H2CO3, those ones have oxygen in them. So we call them oxy acids. Oxy acid because they have oxygen in them. The other group depends on whether they have one replaceable hydrogen ions, that is monoprotic acid, or two replaceable hydrogen ions, those ones are diprotic acid, or maybe they have three or more. If they have three, like this phosphoric acid, then we call them triprotic acid. We can also have acids that have more than three. We call those ones polyprotic acids because they have more replaceable hydrogen ions in them. Acetic acid, noted very well. It looks as if it has 4 hydrogen atoms, but only one of them, only one atom there is replaceable. That is the last hydrogen. That is a ionizable hydrogen ion in acetic acid. Some people call it ethanoic acid. That is the IUPAC name, ethanoic acid. So it has just one replaceable hydrogen ion in it. All right, so let's take a step further. Let's take a step further. All right, so we can also have strong acids. Strong acids ionize completely in solution. Weak acids ionize partially in solution. Examples of strong acids are HCl, the hydrochloric acid, then we have the H2SO4 and other examples. So weak acids can be H2S, hydrofluoric acid, phosphoric acid, cyanic acid. Those ones are weak acids. Now that we know the Arrhenius theories of an acid, then what is an Arrhenius base? What is an Arrhenius base? An Arrhenius base produces hydroxide ion when it dissolves in water. An example is sodium hydroxide, potassium hydroxide. And based on that, we can easily see that Arrhenius acid releases hydrogen ion or hydronium ion in solution, Arenos base releases hydroxide ion in solution. But another definition is by Bronsted and Lowry. They said an acid is a proton donor. Any substance that can donate proton, whether in the gas phase or in solution, we call them acids. And any substance that can accept the proton, we call them a base. So that definition goes, it's broader than that of Arrhenius because it accommodates whether it's in solution or it's not in solution. And we have the Lewis theory of acids and bases. You know, Arrhenius' theory talks about hydrogen being able to donate hydrogen ion or hydronium ion in solution. Bronsted talks about proton, maybe proton transfer, proton acceptor, or proton donor. But in terms of Lewis theory, Lewis looked at an acid or a base as a substance that can transfer electron, whether it can accept electron pair or it can donate electron pair. So a Lewis acid is an electron pair acceptor. It's just like this. If you have a lot of money, you know, I'll be telling you, take this money. You'll say, no, you don't need it. That's because you have a lot of money. But if you don't have a lot of money, then if I give you, whatever I give you, you may like to take it. So Lewis acids are electron deficient. That is why they are electron pair acceptors. And Lewis bases are electron sufficient. In fact, they are electron rich. So that is why they can donate electron pairs. Example of Lewis base is ammonia, this NH3. An example of Lewis acid is this proton, H+, it has lost its electron. So it doesn't have any electron it can donate. All right. So let me flash this quiz to you. I will upload the slide on the LMS so that you can attempt this quiz. So look at all these substances, H2SO4, hydrogen chloride gas. This is hydrogen chloride gas. So look at hydrogen chloride gas, look at hydrochloric acid, and classify them whether they're Arrhenius acid or Arrhenius base, or Bronsted acid, or Lewis acid or Lewis base. So group them based on that. We don't have much time left. So we will meet in the chat section on LMS. So I may need to stop this class. Thank you very much for listening. And I hope that we'll be able to chat more in the forum. Okay.